guys, Eddie67716 here, and welcome back to my 8th redstone video. Now in this video we are going to be looking at pulse extenders, which are devices that extend pulses, and monostable circuits, which do the exact opposite, they shorten pulses. Now just before I get into this video, I'd like to say that if you've been enjoying this type of content, why not leave a like and subscribe to my channel, and let's get into it. Now, a pulse extender does what I said it does earlier. It extends a pulse, where they're self-explanatory. So what you can do is, the main simple ones you can do are usually repeater chains like this, where you have a shorter tick of a repeater with a longer ticked repeater such as this. So this will extend the pulse for 4 more ticks. Now, it depends on what power source you need for how you build this thing. So say a button which usually has 10 ticks, it will charge this up so there won't be any time where that's off. Whereas with an observer you generally need like 1 on 1 tick, 1 on 2 ticks, and 1 on 4 ticks. But this is generally for buttons, so it's a bit simpler. And depending on the way you power, you can always chain repeaters to make it longer, but then this can sometimes get a bit complex, you see. And yeah, pulse extenders are kind of strange how you do them. Now just a second to tell you, one thing you can't really do is you can't really power a pulse extender like this, or you have a circuit that will never ever turn off. So this will always stay on. Although if you do use a comparator, you can make another design for this, which does actually turn off eventually. But yeah, this depends on how you do everything. And then you need space here too, so that's a very short pulse extension. But yeah, so there are a couple of ways you can build these things. Now, this repeater locking design is slightly more compact the way you use it. So if I use this, you can see that this repeater locks this repeater until this repeater turns off. So that extends the pulse. And then I've changed it off here, so it also locks for 8. So it depends on the circumstance whether you want to use that one or that one, whether you need it narrower or whether you need it broader. It depends on what you need and stuff, like I've said before. Now, what are pulse extenders actually used for? Well, this is one of their main uses. It's to alter a piston timing. So you can see by this setup, what I need is this piston needs to extend its block before that piston extends its block. But this piston has to retract before this piston retracts. So this is what this pulse extender here is for. When I press this button, you can see that it does what it needs to. This keeps this piston on until this one retracts. So this is one of the most common uses for shorter pulse extenders, such as these examples. Now, for a longer pulse extension, such as when you need to open a door, and then it needs to stay on a little while even after the button you've pressed to turn off, a medium pulse is better used by a comparator pulse extender, or as I like to call them, a flux capacitor. Their main downside, as stated here, is that they do take time to charge, and yeah, like I've said, I'd like to call them a flux capacitor. So if I press this button, you can see this lamp stays on for a reasonable amount of time before it turns off. As I've just said, they are often used for doors to keep them open while you walk through. It's generally a good idea to use these for all your sorts of piston doors, jeb doors, or secret doors, so it gives you enough time for you or people who want to walk through the door to get through. A flux capacitor has one disadvantage. Generally when you use more than 6 or 8 in a circuit, then that gets too many for a button to do, and it gets to a point where it's too big that it's impractical, and there are better uses. So you can see from this one that it doesn't need a separate circuit to help it charge, because the problem when you make these flux capacitors way too big is you need a spare flux capacitor to keep them on. Like in this example here, it needs a secondary flux capacitor to be able to power long enough for this flux capacitor to charge up. So they can get really, really big, so at this point, this circuit is actually very impractical. It's going to take a while to turn off, by the way. I can just see signal strength. It says it's at 8, now it's back to 7, now 6. Yeah, the whole point of these is to extend it. Since each one takes a tick, it means that how many ticks you want it to go through multiplied by like signal strength is roughly how long it will be on for. Now for a longer pulse extension, an ether hopper pulse extender takes up a lot less space than the flux capacitor, and unlike a flux capacitor, it doesn't need to be recharged. So what this does is, the only difference between this and an ether hopper timer is that the piston at the output has to be a normal piston, and the one at the input is a sticky piston. So if I press this, you can see that's going to cycle through the items until they go like from one side to the other side, and then they're gonna cycle back. So like, it takes 4 ticks per item, and then multiply that by 2. So like 2 items would be like 4 times, 4 ticks times 4, so that'd be 16 ticks. So yeah, these are used for much longer pulse extensions, and they take up a lot less space than a flux capacitor does. Now, for the next section on monostable circuits. Now, a monostable circuit is the exact opposite of a pulse extender. Whereas a pulse extender would extend a pulse beyond how much is inputted, this will shorten the pulse. These are used in very specific circumstances, as defined as here. Now, like I've said, it's just shortening a pulse, so it's the opposite. Now, one-tick monostable circuits are really important to know, because you use them when you need a piston to have a one-tick pulse. A one-tick powered piston will, if it's a sticky piston, it will push out its block, but it will not retract it. Whereas if it was a 2 or more ticks, it would expand, and then it would retract it. So if I press this, you can see that it has one tick powered this piston, so it's spat out its block, but it hasn't retracted it. But then to retract it, you can just press it again. These are often used in toggle flip-flops if this is a redstone block, but I'm going to teach a bit more on toggle flip-flops in a later video. Now this is another design. This one uses a line going through a piston, and then the piston's powered, so only like one tick goes through, and yeah, you can see that that also does the exact same thing. This likewise, except for the fact that this requires more repeaters and less blocks, and it requires an extra space for the piston to expand and retract its block. As you can see, it also is a one-tick pulse. Now this one is for those you Luddites who hate the noisy piston circuits. This design uses just redstone torches, which is quite a strange looking design, and it's kind of funny. So you can see, yes, it does expand and retract the block in different cycles. So yeah, these are usually used in toggle flip-flops, but they have other uses. You can also make a monostable circuit with a varying pulse length. These can be used in different circumstances depending on what you need. So this design here is one of my common designs, using a comparator on subtract mode as a redstone valve, as I like to call them, and it's fed in through this repeater on a 2-tick delay. Unfortunately, they used to be able to do a 1-tick pulse like this, but they've removed that feature. But they can do this if it's on a 2-tick pulse. So yeah, these are not as good as they used to be. And then they can be set up like this. Now if you use this design, which is longer but narrower, you don't need to worry about whether it's on subtract or compare mode, because it will do what it needs to in either mode. Whereas this one, it has to be in subtract mode. And then you can always expand it like this for a varying pulse. You can also use an ether hopper delay circuit, but I'm going to show you how to build them in the next or a later tutorial. So these are generally all the types of monostable circuits you need to be able to build. Although there is actually one more design I could show you, but it's a bit bugged, so I'm not even sure if it can be done. Yeah, so here is the 4-tick hopper design. This is often used when you want like one item transferred through a hopper and only one item. So you can like use this circuit, which would like give a 4-tick pulse item. Although, or was it a 4-tick did 2 items? I'll just double check this right now. So here I built a little circuit to extend it to see if it only allows 1 or 2 items. So if I press this button, you only allow 1 item, so yes, that's Good, my calculations were right. Although, it did power this thing somehow. I'll just try with a chest instead. So if I press this with the chest here now... Yeah, only allow one item through. So yes, this is good when you only want one item to go through a hopper. So yeah, those are some of the main things you can do with a Monostable circuit. Okay, so that's basically everything I need to show you of the basics on Monostable circuits and pulse extenders. Now I'm going to transfer to my machine building world and show you a few examples of when you want to use these circuits. Okay, so I'm at this gem door that I built in a previous tutorial, the one I believe I did on pistons and torches. So, if I want to make this door open for a while before it turns off, I can always use a pulse extender here built out of comparators or flux capacitors. You should know by now that I like to call them. So now if I press this button, it should turn on, but take a little bit of time. And always, if you want to extend it, you can always move everything a little bit further away, such as like this, and maybe this will be a slightly better thing. So, if I come here and press this, then that gives a good amount of time to make it through before it closes. So, it's always a good idea to add usually a pulse extender, usually a flux capacitor is the best choice. Whereas if you really want it open for a long time, it's best to use the ether hopper pulse extender design. This lighting is pretty good looking, but boy does this lighting stink of pre 1.5 redstone. I mean, look at it. It's just a lever with redstone heading to some lamps. I mean, it's pretty cool, but there are just better ways of doing this now. I mean, we've had so many updates since 1.5, and I'm going to show you the new, more sleeker way to light your houses. Now, I'm actually going to show you the process of how to make sure you can do a redstone circuit. Now, generally, the consensus is that if you can power pistons and stuff in the right order you can with just levers placed on blocks, then you should theoretically be able to do that with redstone. So, what I need this to do is, this is what it will look like when the switch is off. But what I want to turn on is it needs to lower this block, power this piston for a little bit, then turn this one back on. And then when I want it turned off, it pushes that down, powers that piston for a bit, and then turns it back on. So since this piston in the middle is almost always on, it will be powered by a NOT gate. And then I can show the basic process again, like when this lever's on, it does that, it powers this, etc. And then it does this when it's off. So, since these pistons only need to be turned on just enough to eject the block, they just need to be powered by monostable circuits. And since they only need to be powered by monostable circuits for a short time, you only need a 1-tick pulse, and they're pretty easy to build. All you need are sticky pistons and observers. Here I have just installed them, so now I can get rid of these levers and show it in like this. So, like when it turns on, this powers, and then it pulls that up. And then when it turns off, this goes down, this powers, and then it turns back on. So I've got the monostable circuits in. Now the key is, each circuit needs to be powered differently. Since this circuit needs to be powered when it turns on, we'll need a rising edge circuit here, which this is the lever I've got installed. We'll just need a repeater, and then the redstone can just go into this piston. And since this one is falling edge, it needs a redstone torch. Then the redstone needs to come up and power. Now all we need to do is a circuit that powers in the rising and falling edge strokes, so aka when it turns on and off. This is pretty simple. All you need is a observer. So now if I can get these up, we can see what we've actually got so far. So if we try turning it off, it's not doing anything because this is not down long enough. So what does that mean? It means what we're going to need is a pulse extender here, and the main reason this has to be bulky is because I don't really know any good very small pulse extender designs. Maybe some vertical ones, but I'm not quite the best redstoner. There are redstoners of much better regard than me. But anyway, what I've done here is a pulse extender with 3 repeaters to make sure it gets the long time, and there are llamas in my redstone pit! Get away with you. So now, what this should do now is hopefully this piston will go down before that piston can turn on. So what is happening is these are powering too soon. So I need to add a delay here. I'll try a 3-tick delay for now. So I destroyed the block. So now, if I turn this off, and then I turn it on, and back off again, you can see that now it works. Now, one key to redstoning is to see if you can shorten your circuits without breaking them. Because the more compact you can get the redstone, the better it is. So, I'm going to fiddle around with this to see if I can compact it more. It's a good idea to see if you can do better than what you think you can do. And then to cover all this up, the only thing you really need to make sure is this place can only be covered by a slab on the top. Otherwise, it would cut off the redstone signal. And then the whole thing wouldn't work at all. Or would it? Maybe I'll just try it. Yep, definitely not. So you need a half slab here. I've tried shortening it, but I can't seem to get it to work, because if I try to remove the NOT gate to a location over here or here, it would just bud power. Maybe it would work if I do under the glowstone, but I can't really be bothered trying any more than I have, so this is the final design. But as a plus note, it's inabusable. Like, maybe we'll have a very small lapse, or the block does get in the wrong place, but it doesn't mean you have to rebuild the whole thing again. So, you hear this? If you ever watch this green, this redstone is green proof. Just to note that when you cover this up, you will need to place a slab on this area, otherwise the redstone won't be able to go anywhere. But other than that, the whole thing should be coverable by blocks without breaking anything. And I'll just cover this up and make sure it works. Oh dear, oh dear, oh dear, where did they go? You did not see that. Anyway, this is just to tell you that it does work. Now all I gotta do is install it in my shack. Okay, I've managed to get all the redstone to put it into my shack. So if I flick this lever, it's on, and then if I flick it again, it's off. Well, that's like coming in from the sides, because I haven't yet covered it up. But this is the redstone I've had to build. A piston with a block powering this line, with a repeater to make sure it doesn't like burn out, lose its signal strength, then reaches out to this part of the circuit where it has the pulse extender here, the 2 monostable circuits here, to the pistons here, and that's how it works. So that's on, and that's off. Although the piston still shows, but haven't yet got to more complex redstone yet, so I'll show you more on how to head down with circuits in a later video, but for now, it works. Another common use for monostable circuits and pulse extenders is they allow you to get timings on a mob farm to make the mobs like flow wherever you want. So the most common mob farm designs of today usually use a water flush system that flushes it out. Then after it's flushed out, it will like pick the water back up again, and then it will wait a while before it flushes it back out. So how we usually do this is we use a rising edge, falling edge monostable circuit, also known as an observer. And let me just get this on the side. Usually we chain these somehow. This was a little bit trickier before the observer was invented, I'll tell you that. But yeah. So what we often do is we'll have an ether hopper timer rigged into either some sort of delay circuit or an ether hopper pulse extender. And I'll just start building one here. Just put redstone here and a repeater. This thing keeps getting updated. But yeah, I'll just build a pulse extender here. And yeah, this thing takes a while to build, so I'll just show what you need. You need your comparators, you need your hoppers here. They both have to face each other. Then you need redstones here and here. Then above the exit side, you need a normal piston, and then on the entrance side, you need a sticky piston. You need redstone block above it. You use some sort of torch lock system, but generally the piston one is easier, but unfortunately for you Luddites, I'm not going to show you how to build the torch design. And then just need the input, and an item that can reference roughly how long we need the water in. I'd say about half a stack should theoretically be enough. And then over here, this can, like, you can pretend this is hooked up to like an ether hopper timer, which is basically this, but with sticky pistons on both ends. So after this runs its whole course, I'll just make sure everything is working. So now if I power it, you can see that's turned on, it's dispensed the water, and after a bit of time it will like go through its course, and then the water will be drained once this gets updated again. Although, come to think of it, I think this is more than plenty of time, and I keep forgetting that I've got to double how long everything takes, which hopefully I'll get used to doing that properly, because I think this is a more realistic time. And yeah, so then you can rig this up to a hopper timer, which I'll build quickly, which is basically just the same thing built there, but with pistons, but it has to go sideways. So, you can actually do sideways or whatever way you want, but usually I like to build mine in the sideways way, like this. And then put my hoppers here. And this can go on a longer timer, so maybe a stack would do the trick. And then I'll just add in the leftover blocks needed. No, that goes there, and then the redstone here. And then you can add a toggle. Huh. Oh, I put the wrong block. So yeah, this is a basic circuit you can use for a mob farm. A bit of like fine-tuning stuff could be done, but then this circuit can run into like a redstone line with a torch hopper to power multiple levels. But I'll do vertical redstone in a later tutorial. But anyway, this right here is the whole basis behind these machines. And I think this could be cut in half. Well, it depends on how long you need the mobs to spawn. In some areas you'll need a longer delay, others not so, and yeah, it depends on circumstance, like most things I say. Anyway, this is going to be the end of this video. I hope you did enjoy it and that you learned along pulse extenders and monostable circuits, and hopefully you managed to get around some redstone areas that is just hard for most people to get their brains around. Anyway, my next video on redstone will hopefully be one on, I believe it's going to be on toggle flip-flops, which they are one of your more important circuits. Then later on I'll do one on just like normal circuits. Then some later on I'm going to do on vertical redstone and on flying machines. So stay tuned for that type of content. And very soon I'm going to be doing automation videos where I like show you how to like automate stuff like XP farms and sugarcane grinding and everything like that. So stay tuned, and if you did enjoy this content, please leave a like. If you'd like to show some support to my channel, you can subscribe, and I'll see you in the next video. Goodbye!